Hello, this is our week 2, day 3 teach video on solving equations, and this is going to involve distribution since it's got the parentheses there. I'm going to show you how it goes through our DCID model, our DCID method. And I'm going to show it algebraically. You can do it with the sketch method that we've learned before, but I'm going to show this one algebraically. Since this does have the parentheses, our first step is to distribute, and I'm just going to remind us that when we distribute, what we're talking about is we're going to be multiplying. So the distribution step is a multiply step. So I take this number 2 that's outside, immediately outside the parentheses, and I multiply it by whatever's inside the parentheses. And I make sure I multiply by everything inside the parentheses. I have to do 2 times 2x, which is 4x, since 2 times 2 is 4, and the x comes with it. And then I do 2 times 1, which is just 2, so then I have plus 2. On the right-hand side, there's no parentheses, so there's nothing to distribute or multiply, so I'm just going to write it down. Now that's the distribute step, and we've done it. Now we're going to look at the combining like terms step. Now, in order to do this, I'm actually going to look at just the left side and the right side, but to emphasize it, I'm going to scribble over the side that I'm not looking at. I don't want y'all to scribble over on y'all's problems, but I'm just trying to emphasize what we're looking at. So I'm going to look at the left side, which means I don't want to look at this right side, so I'm going to scribble over it. And I'm looking to see if there's anything over on that side that's alike. Well, I've got 4x's and I got a 2, but in order for them to be alike, they either both have to have x's or both not have x's. So I don't have any like terms on this side, so I'm not going to combine anything. I'm going to move my scribble over to this side, and now I'm just going to look at my right side. And I've got sort of the same thing going on here. I've got 3 x's and an 8. If they both had x's, I can put them together and make an 11x. Or if they both didn't have x's, I could put them together and make an 11. But since one of them has an x and the other one doesn't, they are not like terms. Like terms have to have the same letters or letter combinations or no letters whatsoever. So there's no like terms to combine here. I'm just going to move my scribble off to the side. So I don't really have the combine like term step. You don't always have every single step in the DCID method, but this is how you would go through it while you're working a problem to check. So now I'm going to look at the next one, which is the isolate, because I do have an isolate step, in fact, several isolate steps I need to go through. I notice first with the x's, I've got x's on both sides, the 4x and the 3x, and I also have constants on both sides, the 2 and the 8. I always like to do my x's first. You want to get your x's together on the same side. And I always like to move the one that's got the fewer x's. So 3x is fewer than 4, so I'm going to move the 3. And I'm going to do it with opposites. Notice the 3 is a positive, and the opposite of a positive is a negative. So I'm going to use a minus 3 to move it. Now 3x minus 3x is 0x, so it goes away. But remember, one of our steps or one of our rules was that you have to do the same thing on both sides. So if I minus the 3x on the right, I have to minus it on the left. So now I just do 4x minus 3x, which is just 1x, because 4 minus 3 is 1, and the letter comes with it. I didn't do anything with the 2. It's still there, so it just comes down. I didn't do anything with that positive 8. It's still there, so it comes down. Now I'm left with 1x plus 2 equals 8. And again, you can leave the 1 there if you want, but you don't have to. Now we want to get the x by itself. There is a 1 there, but there's also a 2 there. And remember, when we do this isolate step here, if there's an addition or a subtraction, we do that first. Now the 2 is connected through addition, so I'm going to move that 2. And once again, we have to use opposite operations. The opposite of addition is subtraction, so to get it away, I would subtract the 2. And 2 minus 2 is 0, so it's gone. But what I do on the left side, I have to do on the right side, so I'm going to subtract the 2 again. And then I have 8 minus 2 is 6. On the left side, I've still got this 1x, so I'm just going to move it down. Actually, I'm done here. I don't really have to do this last step. That's a divide step. Because if I were to divide, because we would say, okay, that 1 needs to move, and it's connected to the x through multiplication, and the opposite is division. So you could divide by 1, and 1 divided by 1 is just 1, so it just goes away. And over here, 6 divided by 1 is still 6, so you haven't changed anything. So if there is a 1 there, there's no reason to do the divide step. If there's anything other than a 1, then yeah, you have to do the divide step to move it away to get the x by itself. But that 1, like I said, you can write it, but you don't have to. It can just become part of the box. So our answer is x equals 6.